Hey there, ladies and gentlemen. So we are going to go over the answers to the Modern Atomic Theory review sheet. I think this is going to go pretty quickly. It's only 5 slides. We'll see how we do here. All right, and the first section here, this is all history. And to be honest with you, sometimes we go really in depth with this, sometimes we don't. You need to make sure you know what your teacher is asking you to know, because it varies from year to year. The first section is about the physicists that put the electrons on orbits around the nucleus. That's Niels Bohr. He called those orbits energy levels. And then we talk about how it's difficult to know the location and the velocity of an electron at the same time. That's the uncertainty principle, which was completed by Heisenberg. There are letters to describe the energy level around an atom, but we use letter N to describe what the energy level is. So if we say that N is equal to 2, then the energy level is 2. Whereas when N is equal to 1, we might say that's the first energy level. Now, we can also subdivide these energy levels into sublevels, the S, P, D, and F, and then within those sublevels there are things called orbitals. And those orbitals are where the electrons reside. Now, we also talk about how the electrons can be at the lowest state, ground state. The outside electrons are called the valence electrons. And electrons get excited, or to go back to the ground state, they go back and forth. And when they do that, they give off a photon. And then from there, we talk about how the electrons are arranged around the nucleus. And those arrangements are called electron configurations, which electron configuration is the whole 1s2, 2s2, 2p6 stuff that we've been doing. Okay, let me show you some answers here on the next page. All right, so in 3 through 7, you can obviously see the answers. There's one easy way to do that, and I'm going to go over that one first, and then I'll go over the other way. So first, these superscripts here, 2, 2, and 1, are the electrons. And so if you go 2 plus 2 plus 1, you get 5. Very good. 2 plus 2 plus 1 is 5. And then you look up what is element 5, and that's boron. So if you check the others, you'll see the exact same pattern. If you just add together the superscripts, you can identify the element. So we have 2 plus 2 plus 1 is 5. Then we have 2 plus 2 plus 6 plus 3, 2 plus 2, and that is 14. That's why that's silicon. And then we have 2 plus 2 plus 6 plus 2 plus 6 plus 2 plus 3, which is 15. That's one. No, that's not 15. It's 23. Sorry about that. Whew, my math skills, they're getting shaky. All right, so let's keep going here. Then we have 2 plus 2 plus 6, which is 10. That would be neon, and of course 2 plus 2 is 4, that would be beryllium. And that's one easy way to do it. You just add together the superscripts, okay? All right, let's talk about the other way to do this. If you know how the periodic table is arranged, here's the periodic table, we can also identify the elements pretty easily. And let's do that last one, that vanadium one that I struggled with, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. Let's look at that one. And vanadium is right here. Okay. So, if we look and we notice that the periodic table actually is divided into regions, like the s orbital region, the p, the d region, we will notice that in order to get to vanadium, we have to do 1s, 2s, 2p, 3s, 3p, which goes all the way to 6, 4s, that's 2 wide, and then this is the third element over in the 3ds. Cool? So if we understand how the periodic table is arranged, where the S, P, D, and F sublevels can be found, that makes this so much easier. All right, now let's take a second and look at the answers to 8 through 13. So, in the first one, we find calcium on the periodic table. And calcium, as you probably know now because you found it on the periodic table, has 20 electrons. And so we have to describe where those 20 electrons are using Aufbau's order that's on the back of your periodic table, or using the pattern that we see below. So if we go 2, 2, 6, 2, 6, 2, That adds up to 20. And guess what? There's calcium right there, and the last piece should be 4s2. Fantastic. Now let's do lithium. So, when we find lithium on the periodic table, lithium's only 3 electrons. So we start at the beginning of off-Bose order, which starts off 1s2, and then the next piece is 2s2 on off-Bose order. But lithium's only 3 electrons, so we have to stop. We can't fill it up all the way. And the way I usually explain this is that the S is like a bus that only has 1 seat for 2 people. The P is like a bus that has 3 seats. It can hold 6 people. You know what? Sometimes I get on a bus that has 3 seats, but only 2 people get on. So it's totally okay to say 3s3p2 or 4d5. It's okay if you don't fill up the bus because that happens all the time. So in the case of lithium, the 2s1, that's a S bus or S sublevel that's only halfway full. Cool? All right, let's move on to argon. I think for argon, we're going to use the other method. We're going to go and find argon on the periodic table. We're going to see that argon is right here. And it is 1, 2, 3 levels down on the periodic table. It's in this P area, and it's the 6th one over, right? It's the 6th one over. So argon is going to end up at the very end with 3p6. So if you write down 3p6 as the ending, you can build up to 3p6, and you'll have the configuration for argon. Go ahead and try that for iodine, rubidium, and zinc. Oh, excuse me, I had a hiccup there. I know that's not odd. All right. I'm hoping you've had a chance to check by now. Iodine is way down here on the periodic table. It's 1, 2, 3, 4, 5 levels down. And it's the 5th one over in the P area. And that's why it ends with 5 levels down in the P area, 5th one over. And so then you use off-Bose order just to build up to that point. Same thing with rubidium. Rubidium was 5 layers down, but it was in the S area, so it ends with 5s1. And then zinc. Zinc, you should be able to get this by now. Zinc is right there. It's the 10th one over in the D area. This is actually a great time, now that we're dealing with zinc, to remind you that that the D area starts with the 3 Ds. Even though you're 4 levels down, the Ds are off by 1. And you should see that in off-Bose order. All right, let's see what else we can learn. All right, in 14 through 19, we're actually using the same answers we just used. I don't know if you realize that, but this is the same answers 8 through 13, just being referenced in a different way. First, they're asking for how many valence electrons. The valence electrons are the highest pieces, the last pieces. And so I've rewritten those here, the highest for calcium, and by highest, oh, you know what? I'm going to clarify that, because some of you didn't understand. Calcium had a 1, 2, 2, 3, 3, and 4. Obviously, 4 is the highest number. That means the highest energy level for calcium is the 4th level. Let's go to argon. 1, 2, 2, 3, 3. Both of these are on the 3rd level. Those are the highest. So I only rewrote the last pieces that have the highest. I did also include some lower pieces just so that people don't get confused when they're looking at this. Like iodine is 5s2 and 5p5 on the highest level or valence shell. Another way you can figure out the valence electrons is counting. I'm pretty sure you can count. Here's iodine right here. And if you count 1, 2, 3, 4, 5, 6, 7, you can see how many valence electrons it has just by counting. So check out the other answers. All right. So that's pretty easy. You just look at the last piece and you can figure out what the valence energy level is and how many electrons are in there. Here we were showing those electrons as arrows in orbitals. I want to remind you that the D sublevel had 5 orbitals and that you can only put 2 electrons in one of these boxes. So 2, 2, 2, 2, and 2 obviously makes 10. And each orbital box can hold 2 electrons. When we did this in the lab, we spread the electrons out. We put 1, 2, 3. Maybe we ran out of electrons. Maybe we had more. 4, 5. And once we had 1 in each of them, 1, 2, 3, 4, 5, we then came back and we doubled them up. 6, 7, 8, 9, 10. So that's what's going on here. We just took the calcium and we wrote out all those arrows. We did the lithium. Notice there's only 1 arrow in the 2s. And we did the argon, and they were all doubled up.
Try.
So at this point, you're probably like doing a really good, I don't know, trying at your homework. I hope that's the case. So we only have a couple more questions, and then we're all done here. Mendeleev put the periodic table based on atomic mass and properties. What model of atom do we need to improve upon from the Bohr model? That's the quantum mechanical model. That's this SPDF stuff we're working on. And then we had the trends for ionization energy, shielding effect, and atomic size. Make sure you know which ones are the smallest and the biggest. I like to say that helium is small and the francium is big. I like to use those 2 points, helium and francium, to really kind of anchor my understanding of the trends. All right, you guys have a good day, and don't forget, there we go. Yeah, that was a lame ending. Sorry about that.